I'm going to begin the process of developing the unit circle. This video would be for perhaps the grade 11 university preparation course for the Ontario curriculum, or also for the advanced functions course for a little refresher. So let's say that we are going to plot a point here on the Cartesian plane, and the point's going to be around here-ish, and then I'm going to connect the point to the origin like this, and then I'm going to swing it around the origin to map out a circle from this point. So just bear with me and pretend that this is going to be a circle. Okay, so not the worst circle I've ever drawn, but of course not perfect. So we've spun this around, and what we'll do now is we will drop a perpendicular from the point to the x-axis, and then we've drawn ourselves a right triangle. Of course, because we've connected the dot or the point to the origin, and then we spun it around to create a circle, this is going to be the radius r, and from this point we've got obviously x and y coordinates. Those are the ordered pairs, or the ordered pair, and we've got this then would be the distance in the x direction to that point, and this is the distance in the y direction to that point. I also want to have us recall the trigonometric ratios, and of course, sorry, we're talking about a rotation here of this terminal arm. So that's where the angle of rotation, when starting from the x-axis, the positive x-axis, rotating in a counterclockwise rotation, that angle will then terminate at this ray here, this line segment, which is then called the terminal arm, because the angle terminates at that point. Okay, so this is the angle that's been rotated, the arm's been rotated through, and then hence it forms the right triangle. And if we remember from maybe last year or the year before, when we started learning about trigonometry, we learned 3 short words, a little shortcut, and those acronyms were SO, CA, and TOA, meaning the sine ratio is determined by the opposite side divided by the hypotenuse, the cosine ratio is the adjacent side divided by the hypotenuse, and the tangent is the length of the opposite side divided by the length of the adjacent side. Okay, so keeping all that in mind, what we're now going to do is we're going to look at this, focus on this angle theta, and we're going to write out what the sine of this theta angle would be. So sine theta, maybe I'll put this over here. So sine theta, well, it's opposite over hypotenuse, and the opposite side of this angle is over here, so it's across the triangle. That's the opposite side, and it's opposite over hypotenuse, which would be y over r. Then if we go to cosine, the cosine of the angle theta is adjacent over hypotenuse, and the adjacent side in this case is this side beside, adjacent means beside, this side adjacent to the angle, therefore, and it's adjacent over hypotenuse, which is over the x over r, like this. And then the last one would be tangent, which is opposite over adjacent. So tangent theta being opposite over adjacent is y over x. Okay, so far so good. So now what we're going to do is we're going to assume that this circle is the unit circle, and a unit is just one measurement long. So we could talk about unit squares, unit triangles, and even unit cubes. But in this case we're talking about a unit circle, and the unit circle has a radius of 1 unit. So if we say that the radius is 1, then that denominator is 1, and therefore sine theta just equals y. If we apply that same logic to the cosine, then the cosine ratio is just equal to x, because the radius is just 1. So now we know that sine theta equals y, or conversely y equals sine theta, and x equals cosine theta. So if we look back at this ordered pair xy, we can now write it as cosine theta sine theta, where the x values are determined by the cosine of this angle, and the y values are determined by the sine of this angle. And those would be the ordered pairs of all the points around the circle. And now we see over here that tangent theta equals y over x. Well, we know now that y equals sine theta and x equals cosine theta, so we can just substitute that into here. So therefore, tangent theta equals sine theta over cosine theta.